Nintendo Switch. Let me show you what's going on. I cleaned this up a little bit so that I can inspect the damage. This is a DIY port attempt by the device's owner, and they made a little bit of a mess of it. So that's going to be our job today. For your orientation purposes, this is the area we'll be working on. And when I'm working on side A, this is where we'll be. We're going to be switching over to side A for the time being because I need to finish cleaning out these anchors. While I'm setting up my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the Amazon associate links in the description. If you head to my video description and click on one of these links and buy any of this equipment, or if you buy anything during that session, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. In order to assist with the cleanup, I'm going to flood these anchors with low melt. It may seem counterintuitive to put more solder in. Trying to clear out a little bit of high temperature solder compared to a lot of low melt is actually more difficult. Now, straight away we have a few problematic areas. As you can see, all that's left of the pads here are the two vias. We're probably going to have to run long jumpers to these. This one is not so much of a problem because of its location. It's actually located at the top. We can run a jumper from that via and cover the whole pad. These two problematic vias we're going to have to run from the test pads. Luckily there are test pads on this side of the board that are attached to these vias. This one is attached to this, and this one is attached to this. So we'll be running jumpers from those to those pads. The non-glare lighting, do some scraping. Oops, didn't need to scrape that one. Sometimes you can be brainless. Okay, we'll have to run a long jumper here, and we'll have to run a long jumper here. If y'all want to have a fun betting game, bet on me getting dock on the first try. Having a station with 4 irons is not always glorious. I've spent an inordinate amount of time untangling all the cords instead of doing work. This will be our long jumper. I'm trying this with the knife tip. It may be a little too big for this, but it does work quite efficiently on these jumpers. So there are constraints in the area you're working. Good solder joint here. That is a good attachment. Excellent. This will be a long jumper. All we have left are the long jumpers. We're going to get approximate here. We'll run a little bit long. Anybody ever seen me tack these down with solder masks? That's what we'll be doing ultimately with these jumpers. But I need to get an approximate place to cut it off. I'm going to give myself plenty of slack to play with. Alright, I'm just going to cut it off way down here for now. Next one we got to run is this isolated guy over here. There'll be some crisscrossing here. And that's why we use enameled wire. So roughly. Very roughly on this one. This has lots of slack to play with. Temporarily bend these guys out of the way so that we can clean. All the flux has to be out of here for the next steps. That one on the via is not one we wanted to play with. Dealing with this long jumper without messing with it is going to be the next challenge. We'll secure that one first. I'm just going to tack it down section by section here. This is not the full cure. This is just getting things to stay in place so we can do the full cure. We're doing a very long route here, so precisely where we want it, so I'm going to go ahead and do thorough cure of it into place. Well, I was. Now it's been entirely uncooperative. And I don't mean like a thorough cure, just to cure it into that spot. And now we route the next jumper. First thing we have to secure is up here though, where we want it in place. Have to resolder that one again. Just not wanting to get into place where we want it. And now you're seeing why I ran the long jumper for those other ones. Trying to solder just on a via is a challenge. A little more safe to scrub off the flux now that things are kind of locked in place. The reason for this is when we go to flow the port in, this solder will wet again. And if it is not held into place by something, the wire will suck up into the solder on the port and we'll lose our jumper. I'm going to cover this one in solder mask and we'll scrape it off after, because I don't want that one to move at all. Everybody's in place. Just grab my big UV lamp, throwing it on there, and I step away and let it cure for 10 or 15 minutes. Make sure it's a good thorough cure. We don't want anything moving, and we'll come back and finish up the job. I hope this video is being helpful to you on your repair journey. Just a reminder, if this is beyond something you want to try yourself, I offer these services. Just head over to micromage.repair, click on free quote, fill out the form, and I'll respond to you personally. We should be thoroughly cured at this point. And we are rock solid. Excellent. Now we're going to need to do some strategic scraping and prep. Scrape the enamel off these jumpers. Can burn the enamel off, but either way works. Do what you're comfortable with doing. Just a tad more. I want it to make contact with the pad. Next we need to tin. Paint our wire. Alright, nobody got sucked up by the iron. That's good news. And that's what a good cure will do. You don't want to lose any of the jumpers into the iron, and therefore you shouldn't lose any of the jumpers into the port. We'll stick to our normal method. Rapid air movement. We'll warm up the board. Let the board do the work of wetting the solder. And put a little bit more pressure on this than I normally would. And continue holding it down until I see evidence of drying. I think we're going to rework these pins here. I wasn't so much worried about these as I am the hidden ones. Feels solid. Doesn't mean everything is solid, but we'll find out. Gee, I didn't notice we were missing filters on Pi 3 USB. That's happiness. Not. You may be asking yourself, why am I not happy to see that? Because I just reworked the port, and I really wasn't looking to have to do any rework around the port. The port is now lower melt solder than most of the stuff around. I really wish I had noticed that before. Good feed through. Now we're going to move slightly up the board and work on these filters just right near the port. Okay, dropping our air to 20% and trying very hard not to reflow the port. I do know that they are not exactly the same size, but I do believe they're in spec. Everything still looks connected. Whoever was attempting this repair chose to use solder paste, and there are still balls in random locations on this board. Next thing I need to do is clean the board thoroughly, clean the port out thoroughly, and we'll be prepared to do a power test and a dock test and cross our fingers and hope we connected everything. Now I'm going to go ahead and test for any other faults because I've already seen too many surprises on this board and I don't want to stick power to it and then find another rude surprise. So let's go ahead and just test for our normal faults and our common fault testing zones here. We'll start our testing around the M92T36 First capacitor we're going to test is actually the one connected to Pi 3 USB on the back. And the line we don't want short of the ground is the one going to the chip. It is not. Very good. Now we're going to follow the capacitors around the chip. Same deal. The lines going to the chip we don't want short of the ground. This capacitor being the exception. It has two lines going to the chip. In that case, you want only one side to be ground. Alright, everything's looking good around M92T36 so far. Check our MOSFET area. No shorts. Check our low filter. Check our test pads. None of these test pads should have a pathway to ground. None of these test pads should have a pathway to ground. This coil should not have a pathway to ground. It should have continuity going through it. It does. Same rules apply around the BQ24193, except it has multiple capacitors with multiple lines going to the chip. Everything seems to be okay. Now we're clear to perform our power tests. The first test we're going to perform is with our 3.5mm to USB-C dongle plugged up to our PSU. And what we want to see here is just a quick jump in amperage and back down on both sides of the port. Looks okay other than the fact that it's stuck. And that looks okay other than the fact that it's just stuck there. Hanging is not really great, but the next test we're going to perform is with our modified iPhone Power Squid, which we have retrofitted with Nintendo Switch and Nintendo Switch Lite battery connectors. And we're going to activate using the OEM charger with a quick plug in and plug out. What we want to see here is just a steady current draw without hanging, which we are not seeing. Yeah, that's not what I want to see here. Okay, that explains it. That's what explains why we're hanging. I don't have the memory module. Memory module has been acquired. Now let's see if I are getting the normal behavior with our dongle. Still hanging. That's more like what we want to see. Try again on the other side. Yeah. Not exactly what we want to see there. Again, that's the most unreliable test we do. It can tell you some things, but it can't tell you everything. Let's see if we get a normal boot sequence. Does appear to be booting. See if we are fortunate enough to get dock. Try the other side. We're not getting dock. Oh, there it is. It's the port. Okay. We're going to have to refill the port and push it down a little bit better. But we know it is achievable. We need all 4 anchors to wet. So that's what I'm concentrating on at the moment. We're going to press down nice and hard. And when these anchors dry, they should hold everything in place real well. I'm going to hold it down until I see everything is dried, particularly the anchors. Okay, let's see if we have dock. Yes, we have dock. Alright, so we didn't get it on the first try, but we almost got it on the first try. We got it on the second try. Excellent. Okay, that's it for this one. I don't have the housing to do any further testing. But if you got value out of this video, I think you'll get value out of this one. And I'll see you there.